Good afternoon, students. Let's start our seminar. So today we are going to continue the topic that we have started last week. Okay? So this is designed for 2 weeks. So choosing when to act. Choosing when to act. So students, basically last week we have discussed about 3 models, if you remember. So the first model that we have discussed was exponential discounting model, right? Exponential discounting model. So we have expressed, so utility, it was intertemporal utility for several periods of time, right? So now it's equal to sum of, we have included that discounting factor, t minus 1 times utility of t, right? So we said that basically here t starts from 1 up to t. In this formula, the main argument was, so we do not see utility as of today as same in the future. We try to discount it. And how we discount it? We exponentially discount it. Okay? Because that delta has that power. We exponentially discount utilities of the future. Okay? This was the first formula that we have discussed. Second one, we said, according to the studies conducted by different scholars, okay, different scholars in behavioral science, they have seen that, you know, that this discounting factor of people is not same all the time. And the studies show that people become more patient. So if they discount a lot for the short period of time, for the longer period of time, they discount less. So therefore, we have, considering that fact, we have considered another model, which is utility, intertemporal utility with hyperbolic discounting model, right? So now we had this t, it is from 1 to t. We have included that hyperbolic discount model, okay, discounting of utilities, right? Of utilities. And here we said our utility of this hyperbolic discounting model is equal to 1 over 1 plus alpha t minus 1. And this alpha, we said, is indeed that parameter which shows how people become patient over time. Last week calculation has really, we saw that in this case people indeed become more patient with longer period of time. And then, students, we have discussed this hyperbolic discounting model is practical and applicable in the case of time consistency. If I said, I will do my homework next month, then if I definitely do it, then it means that I am time consistent. But when next month comes, if I decide, or you know, maybe I should do it after 1 week later, or 2 weeks later. If I delay, then it means I have bias, present bias. So which means that it is time inconsistency. I said I will do it, but I did not do it. Time inconsistency. So therefore, hyperbolic model is not able to control for that time inconsistency issue. So therefore, we have included another model, right? So which considered that intertemporal utility for quasi-hyperbolic discounting model. Quasi-hyperbolic, right? So where we said utility of the first period is not discounted, but, and there is no bias for the present, but bias comes in the future. I said I will do it, but it may change. I may change my mind. So therefore, we have included that beta, which is present bias, okay? And the sum of discounted utility, okay? T minus 1. And now period starts from 2, because first one we don't discount, up to t. These 3 models we have considered, okay? 3 models we have considered. And students, in these 3 models, what we are our assumption is utility of different days we will definitely get. If we say that, on Saturday I can play sports and I will get utility of 3. And we are assuming that I will definitely play sports. All right, I will definitely play sports. But now, today, students, we are going to introduce to these models risk. Which means now my playing of these sports depend on some factors, whether I can play it or not. For example, there is 60% probability then it's going to rain. If it's going to rain, I cannot play soccer. Then that means that utility I cannot play, then utility I get is 0. And there is 40% probability that tomorrow on Saturday that it's not going to rain. If it's not going to rain, I can play sports and I can get utility of 3. So now we are introducing prospects, risk, okay? Now it's not for sure, 5, 4, 3, 2, 1, no. So now we are introducing another model which is going to consider it. So look, if we have probabilities, different probabilities of things to happen, then it means that it is not just utility, but it is expected utility, right? So therefore, today the model that we are going to consider is, students, discounted expected utility. All right? So the formula of that discounted expected utility is, now we are considering utility for t periods, and now we are considering different prospects. Prospect 1, prospect 2, and so on. Many prospects. Okay, different prospects, and I will now explain you. And we are saying that the sum of, students, the sum of discounting factor t minus 1, t is equal to 1 to t, and the sum of expected utility. So now we are including probabilities, okay, probabilities of of a prospect, and utility, okay, of, let's say, xi. All right, for t period. So it's Monday, Tuesday, whatever the day. So now we are going to apply this formula. So now we are saying discounted expected utility. So now probability and those utilities. This is expected utility, and we are going to discount it. Okay, we are going to discount it. So now if it's not very clear, so now with an exercise it will be clear. So now, students, we have exercise 1. Please quickly read it. Quickly read. By that time I will draw a graph here. A table, sorry. Okay, I think you were able to read. So students, now we are making an assumption. A student gets some utility if he plays only computer games. Okay, computer games. So now we are saying that if the student plays 1 hour, let me erase it now. If the student plays 1 hour of computer games, it gives him utility of 1. So 1 hour of computer game is equal to 1 utility of 1, satisfaction level of 1, okay? Good. So this we know. And now, students, according to the daily schedule, during the weekdays, you get no utility from daily activities because you don't have time to play. So, from Monday to Friday, because you have to come, study hard, spend those 12 hours in the library, only studying, you don't have time to play computer games. We are making such fake assumption. Okay? So, you don't have time at all to play. Therefore, you get no utility. But, look, on Saturdays, you have 4 hours to play. On Saturday, look, on Saturday, you have 4 hours to play, which means it will give you utility of 4, right? And the timing is also given. You can play computer games on Saturday from 2 to 6 p.m. in the afternoon. Okay, this is one thing. You have to consider the time because we will include time and risk. Next one. On Sundays, 8 hours. You can play it 8 hours. Okay? You can play 8 hours. And the timing is also given. On Sunday, you can play it 8 hours, okay, which means you can get utility of 8. And the timing, you can play 4 hours in the morning from 8 to 12, and in the afternoon from 1 to 5. Okay? These 8 hours in the morning and in the afternoon. This timing you should remember. Good. And now, students, based on that one, we have the following table. On Friday, I don't get any utility because this is, you know what, I have no time. But on Saturday, I can play 4 hours in the afternoon. It gives me utility of 4. On Sunday, I can play 8 hours in the morning and afternoon. It gives me utility of 8. And on Monday, why it is 8, now I will explain. All right? So look, on the ceteris paribus condition, the statistics in the table represent the day-by-day utility of a student doing homework on different days. Okay? On different days. The assignment is given on Friday morning, similar to the last week. Okay? And the deadline for the submission is on Monday afternoon. The burdensome of doing homework results in this utility of 2 no matter what day it is done. So, now there are, homework is given on Friday. And deadline is on Monday. So, now Saturday and Sunday. So, the student has 4 options. Totally up to student when to do his homework. And we are saying, doesn't matter on which day the student is going to do his homework, it's going to cause this utility of 2. If he decides to do it on Friday, then it will cause this utility of 2, minus 2. Okay? Whole day we have to do the homework, and it will take whole our time. Good. Good. And next one. All right? So, look. Late afternoon on Monday, the results are published, which increases utility of a student by 8. So, when I did my master's, okay, we had a professor called Professor Hai. He used to teach us financial accounting and managerial accounting, those 2 modules. And he used to give us every week 1 assignment. Every week 1 assignment. So, for example, if the total mark is 100, so just 20%, if I'm not mistaken, of that weighting was given for those assignments. The way he used to mark was like this. You submit, you will get full mark. It was his, way of marking for those, okay, assignment. You have to submit. You have to answer all the questions, and he will give you full mark. So now, students, we are saying that whether it's done on Friday or Sunday or Saturday, doesn't matter. Or Monday, he will give you full mark. Just you have to submit. Okay? Not more, not less. Same mark. Like Professor Hai. Okay? We are considering this fact. Look, however, the delay of doing homework on Monday gives utility of 0. If you do it on Monday, it will give you utility of 0 because this utility of doing homework, which is -2, is compensated by utility of the results. You experience this utility of 2 at the same time, your results are published, you are happy. So, in the first half of a day, you were very unhappy because you were doing. In the second half, you were happy, minus plus, and now it's gone. Okay? And from the prospects theory, we know this utility, when it's lost, it's, that lambda is too large. If it's, positive, happy, it's a little. So it's compensating. Okay? We are considering that case. All right. Good. If you understood these arguments, then on the ceteris paribus condition, fill in the following table with day-by-day utility of a student doing his homework on different days. So now we have to fill in this table, okay? So now we are considering on Friday, what if I do it on Friday, on Saturday, on Sunday, and on Monday. How much utility, okay? So decision. Do it on Monday. On Friday. Do it on Friday. Let's consider do it on Friday. So let's suppose the student or the assignment is given on Friday and he decides to do his homework on Friday. I will do it on Friday. Okay? If he does his homework on Friday, then on Friday, is he going to experience utility or disutility or what? Disutility of -2 because he is doing it on Friday. So then on Saturday he can play computer games because he did his homework. So if he plays computer games, he can play 4 hours, right? It gives him utility of 4 hours. Because he decided to do his homework on Friday. If I do my homework on Friday, it will give -2 because whole day I will spend doing homework, which I don't like. And that dissatisfaction level is -2.
So we take it as a -2, right?
Yes, as a -2.
Not from the task, yes? I saw it.
No, it is given now. In the previous slide, I've given it to you, okay? So what day you do, it's -2, okay? That was the decision.
There will be another number like 4 or 5.
-4, if I told you there it gives this utility of -4, then it will be -4. Here is -2, okay? Good. So then I did my homework on Friday. On Saturday I played computer games. I can play. On Sunday I can play how many hours? 8 hours. It will give me utility of 8. Okay? And on Monday, Professor Hai will give me the full mark, which is increases my utility by 8. Okay? Done. Good. So now if I decide to do it on Friday, what about if I decide to do it on Saturday? So which means on Friday I'm not doing my homework. Normally I get the utility of 0. On Saturday, I'm doing my homework for the entire day. Do I have time to play computer games? No. So now it will be -2. -2, this utility. Okay, -2. And then on Sunday, I can play 8 hours of computer games, and the results are giving me utility of 8. Okay, good. If I decide to do my homework on Sunday, then, again, on Friday, no utility as normal. On Saturday, I can play 4 hours. But on Sunday, I have to do my homework. Where it's going to be this utility of 2. And the results will be published on Monday. I will get utility of 8. Okay, utility of 8.
Can you please explain one more time on Monday why it's 8 hours, you said?
It's not 8 hours, results. You submitted, your results on Monday. Because you submitted your homework, you will get full mark. And that full mark gives you utility of 8. Okay? That one. And now if you decide to do your homework on Monday, last day, on Monday, then on Friday, usually we don't get. On Saturday, I can play computer games. On Sunday, I can play computer games. But on Monday, I cannot play. I cannot play. So look, the last point here. The delay of doing homework on Monday gives utility of 0. Because this utility of doing homework is compensated by the utility that you get from results. So it's 0, okay? It's 0. So now this is 0. This is 0. Done. We are done, students, with this one. So look, now suppose you live in a rural village, like a village like my village, okay, where there is 50% probability of power cut on Saturday afternoon. All right? We are saying that on Saturday, right, on Saturday, usually, normally, we get utility of how much? 4, right? And when do I play it? What time? In the afternoon. From 2 to 6. And I'm saying that within this, in the afternoon, there is 50% probability that there will be no electricity. If there is no electricity, I cannot play. Okay, now if the power is gone, so utility I get is 0. And I'm saying that there is another 50% probability that there will be electricity. In that case, I can get utility of 4. Okay? So this is in the case of Saturday. And now, look. On Sundays, there is 30% probability of power cut in the afternoon. And there is 20% probability of power cut for the entire day. So, on Sunday, utility I usually get is 8, right? And I'm saying that there is 30% probability that in the afternoon there will be no electricity. If in the afternoon there is no electricity, I cannot play in the afternoon, but I can play in the morning. So which means how much utility I can get? 4. I am saying that there is 20% probability that for the whole day there will be no electricity. I cannot play in both, in the morning and in the afternoon. Then it will be 0. And what about remaining 50%? 8. Because other 50% says that for the whole day there will be electricity. Okay? So then I can get utility of 8. I think you understood, right? Good. So now, students, considering the issue of time and risk, write the prospects of expected utility for each day. So now, I will draw another table and we will write prospects, okay? Okay. Okay, let's keep it for now. All right. So decision on Friday. So on Friday, students. On Friday. Now we will write prospects. Okay? So now we are saying, what's the probability of having this, experiencing this utility of 2? If I do it on Friday. 100%. Okay? Because I'm doing 400%. There is 100% probability that it will be this utility of minus 2. If I do it on Saturday, so now we have risk of electricity issue. So now here, there is 50% probability that there will be electricity and I can have utility of 4, yes? And there is another 50% probability that there will be no electricity and I will get that utility of 0. On Sunday, another, now we are including that risk one. We are saying that there is 30% probability that in the afternoon there will be no electricity. So I can play in the morning only 4 hours and get utility of 4. And there is 20% probability that there will be no electricity for the whole day and I will get utility of 0 because I cannot play. And there is 50% probability that there will be electricity for the whole day and I can play 8 hours and get utility of 8. And this results, because I submitted it on Monday, I will definitely get 8. So now there is 100% probability of utility of 8. Okay, if I do it on Friday. What about if I decide to do it on Saturday? I decide to do it on Saturday. So regarding this one, I don't play computer, so it's for sure 100% probability of 0. 100% probability of 0. And now I am doing it on Saturday. Whole day I am spending for doing homework. I cannot play computer, which means that there is 100% probability I will have that this utility of minus 2. But on Sunday I can play, so this is the prospect that we can apply. Same. So 30% probability of playing in the morning, 20% probability of not playing at all, and there is 50% probability of playing for 8 hours. And there is 100% probability of getting the results. Okay, good. If you decide to do it on Sunday, so now 100% probability of 0, and on Saturday you can play 50% probability of playing in the afternoon and 50% probability of not playing. But on Sunday you have to do your homework for sure, minus 2. 100% probability of minus 2. And this one here too, 100% probability of getting good results. Okay, good. And
What about on Sundays there is 30% probability of power cut?
here, 30% probability. Here, he is doing it on Sunday. Homework is done on Sunday. If it's on Sunday, you don't play computer games at all.
But we have still electricity cut.
Doesn't matter. So therefore I said that our homework does not depend on electricity. Okay? So here on Monday, 100% probability of 0, 50% probability of 4, 50% probability of 0. Here, 30% probability of playing in the morning only, 20% probability of not playing at all, and there is 50% probability of playing whole day, 8 hours. And there is 100% probability of 0. Okay? This is the case. So now we have prospects, students. Once we got these statistics, then we can apply this formula. So here, A, prospect A, it means this prospects, okay? Prospect 2 is this one. So these are prospect 1, prospect 2, prospect 3, prospect 4. Okay? Of utility. These are the prospects. And now we are saying that we are discounting of the future. We now apply this formula with those statistics that we have found. Okay, now students here calculate intertemporal discounted expected utilities of doing homework in different days with discount factors of 0.9 and 0.6. And we are considering a person as risk neutral because his utility function is linear. If you are going to consider that a person is risk averse, then our calculations will be a bit more time consuming, which you can do it by yourself at home. Okay, as a practice. So now we are considering that 2 students with 2 patients levels. First one, we are considering patient's level of a student is 0.9. 0.9. And now we are going to calculate these students' expected utilities, okay? So with discounted expected utilities of doing homework in different days. Okay, now pay attention and understand how we are going to calculate it, all right? Good. So we are going to find the student's utility for 4 days. 4 days utility. Overall 4 days, intertemporal utility 4 days. And he decides to do it on Friday. So what if I do my homework on Friday? Let me just write it over so we have more space here. So utility of 4 days if I do it on Friday equal. So look, discounting factor is given delta and Friday. And we will consider this one. Discounting factor is equal to 0.9. So now Friday, period 1, t minus 1, period 1 minus 1, yes? Minus 1 times expected utility, the sum of expected, which is, we have to multiply this one to what? There is 100% probability of minus 2. Okay, this is for Friday. But the next day utility, okay, now next day expected utility, we are discounting exponentially. So now 0.9 in the power of 2 minus 1 times 50% probability of playing computer games, and there is 50% probability of not playing. So times 4 plus 0.5 times 0. Third period, third period, so 0.9 in the power of 3 minus 1, third period minus 1 times, we are saying there is 30% probability of playing in the morning only, plus there is 20% probability of not playing at all, and there is 50% probability of playing whole day, 8 hours, plus there is 0.9 period 4 minus 1 times there is 100% probability of 8. So this one. Now if you calculate this one, students, it will give you number, I think I have those calculations, let me write down it for you. So it will give you number 9.8. It's equal to 9.8. Okay, it's equal to 9.8. And now second one. So this is in the case of doing it on Friday. So now let's find it for doing it on Saturday. Utility for those 4 days if the decision is made to do it on Saturday. Again, our discounting factor is 0.91. So let me write as 0 because you already know where those numbers come from, right? 1 minus 1 is equal to 0 in the power of 0 times 100% probability of 0. 100% probability of 0. 1 times 0 plus second period 0.9 in the power of 1 times 100% probability of minus 2. 100% probability of minus 2. Okay? Next, plus third period 0.9 in the power of 2 times. Now, Sunday I can play 30% probability of playing for 4 hours plus 20% probability of playing no hours plus there is 50% probability of playing 8 hours. Okay, good. And last period 0.9 in the power of 3 times there is 100% probability of 8. If you find this, it will give you number which is equal to 8.2. 8.2, okay? You have to calculate. So students, when you come to the final exam, you must have a very nice calculator. It's very important. If you don't have a calculator, and let's suppose you have a similar type of examination question, believe me, just this question, it will take more than 1 hour. So therefore, you should have a nice calculator where you can enter all of these calculations at once. Then you will get the final number. What we need is you must show that you really understand. The remaining is, that just the final result. This is enough. You don't have to show that this calculation is equal to 0. This many decimal values, and so on. No. Just write and results. It's sufficient. Okay, it's sufficient. So next one, and another thing why I'm saying it, don't wait until that last moment. That time you may not be able to find those calculators. If you come with that, Soviet type simple calculator, then you have to do calculations of this one. You have to write 3.789 decimal values plus another one. It will take so much time. So in order not to have such problems, you have to find calculators, okay? And you understand about supply and demand, right? So next, utility of doing it homework on Sunday. So 0.9 in the power of 0 times 100% probability of 0. I think you are following the numbers. Yes? Plus, I'm doing it on Sunday. On Saturday, then I can play sport. I can play computer games. So in the power of 1 times 0.5 times 4 plus 0.5 times 0 plus. On Sunday, 0.9 squared times 100% probability of minus 2, right? This. Plus 0.9 cubed times 100% probability of 8. If you calculate this, it will give you a number which is equal to 6. Which is equal to 6, okay? Good. And the last one, decision to do your homework on Monday. So 0.9 in the power of 0 times 100% probability of 0 plus on Saturday 0.9 in the power of 1. There is 50% probability that you can play 4 hours plus 50% probability of not playing plus on Sunday 0.9 squared times there is 30% probability that you can play 4 hours plus 20% probability of not playing plus 50% probability of playing 8 hours. Okay? And last month, Monday, so 0.9 cubed times, there is 100% probability of 0. If you find this, it's also equal to 6. Okay? So what's the decision of a student to do his homework? He will decide to do his homework on Friday. I will do it on Friday.
So the higher the value means that...
Yes. So now you see, from those 4 days, he is expecting the highest utility if he does it on Friday. Okay? So his decision will be do it on Friday. Good. And now, what if student is impatient? Here, 0.9, it means the relatively patient one. Okay? So now we will consider the student is not patient. So I will quickly show you, so let's do it together. So we are considering that students, that delta, okay, the delta is equal to 0.6. 0.6. So what you have to do, you have to only change these numbers into 0.6, okay? So let me write down, so utility of 4 days, if he decides to do it on Friday, it's equal to 0.6 in the power of 0 times 100% probability of minus 2, right? Plus 0.6 in the power of 1 times 50% probability of 4 plus 50% probability of 0. plus 0.6, sorry, it's not 9, 0.6 in the power of 2 times 30% probability of 4 plus 20% probability of 0 plus 50% probability of 8 plus 0.6 cubed times 100% probability of 8. And this is equal to 2.8. This is equal to 2.8. Okay, 2.8. Next, utility of 4 days if the decision is to do his homework on Saturday. So 0.60. So on what there is 100% probability of 0 plus 0.6 in the power of 1 times. He is doing it on Saturday homework. 100% probability of minus 2 plus 0.6 squared times 30% probability of 4 plus 20% probability of 0 plus 50% probability of 8 plus 0.6 cubed times 100% probability of 8. And this is equal to 2.4. 2.4. Next one, utility for those 4 days, expected utility if the decision is to do it on Sunday. Okay, if decision to do his homework on Sunday. Equal 0.6 in the power of 0, 1 times 0, 100%, plus 0.6 in the power of 1 times 50% probability of 4, right? 4 plus 50% probability of 0 plus, and now it's on Sunday 0.6 in the power of 2 times 100% probability of minus 2 plus 0.6 cubed times 100% probability of 8. If you calculate this one, it will give you a number which is equal to 2.2. 2.2. And the last one left, what if this decision is made to do it on Monday? Utility of doing it on Monday within those 4 days, 0.6 in the power of 0, 100% probability of 0 plus 0.6 in the power of 1 times 50% probability of 4 plus 50% probability of 0 plus 0.6 in the power of 2 times 30% probability of playing in the afternoon plus in the morning only, and 20% probability of not playing whole day, and 50% probability of playing 8 hours plus 0.6 in the power of 3 times 100% probability of 0. Now, if you calculate this, students, it will give you a number which is equal to 3.1. 3.1. So, what is the decision of a student to do his homework? So, it is 3.1. He will decide to do it on Monday. Okay? So, students, let's continue our class. So, we are done with the first exercise. So, now we have second exercise. So, what is intergenerational discounting factor? What was it? So now you all know about discount factor, right? That we have discussed together, which is discount factor. So now we are saying that the one that we have considered, it was individual specific for individuals. But now we are considering intergenerational, which is it is applied for generations. All right? Discount factor. So let's suppose, how are we discounting, utility of our grandchildren? All right, this is that case. So now let's suppose we are getting utility of 100. And how do we see that, utility of our future generations? Do we see same or we are discounting it? Okay, do we see same or we are discounting it? Do you really care about, that your grandchildren who will be living after 200-300 years? I don't think you even think about it, okay? I don't think that you even think about it. But government does think about it. Government. All right? For example, let's suppose one of the biggest problems, especially in developed world, is what? Fertility rate, yes? Fertility rate is now going down and down and down. So, and you must have heard or you must have read some, papers, which they show the outcomes. If that the population, decreases and if it's going to continue in that level for many years, there is a probability of this much that certain nations will disappear from the earth, right? So after 300 or 400 years, specific nation will disappear because their growth rate is very low. So there are such things. So therefore, even though there is 300, 400, 500 years to disappear, governments are taking measures from now. For example, in Russia or some other developed, other way, that growth is negative. So 2 couples are having less than 2 children. So what the Russian government is doing, so now if you are going to have 1 baby, they will give you some financial compensation, right? Which is good money. If you have 2, then they will give you even more. If 3, even more. Just for the sake of encouraging people to have more children. Because there is such probability the Russians, after a few hundreds of years, that thing may happen. So therefore, they are taking measure from now. For current population, it has no effect at all. But Russian government is doing for the sake of hundreds of years from now, a few hundred years of the. But the burden is taking who? Today's population. Which means that we really care about the future. And another thing that we are going to discuss today is regarding climate. Climate. So now we are living in Tashkent in Uzbekistan, everything is normal, no problem, right? No problem, it's okay. So it's no problem. So somehow, if someone is asking you, comes to ask you, we are going to take care about your grandchildren, so you have to pay 50% of your income. How do you think? So you would say no, right? You would say no. So students, because government thinks about the future, all governments of the world, because climate change is affecting negatively, step by step, all countries, they are taking certain measures. And they are trying to minimize the impact. For that one, what they are doing, they are people of today's generation, they are taking some burden. Policies are implemented. Policies always come with cost, which we have to pay. Okay? So now, students, we are considering 3 types of policies. 3 types of policies. Do nothing, climate policy ramp, and immediate action. Do nothing, it means we don't care at all. So we maximize utility now. We produce in maximum level in all capacity, and we drive whatever environmentally unfriendly cars, whatever. We are maximizing our utility. And after 50 years, we are still living. We're still maximizing, but our future generations are. Now, this is the case. The climate change became so bad that people are getting no utility. We are considering such case, okay? In the second one, it's most of the countries are implementing climate policy, ramp policy, such policy. For example, when you studied CIG, we had second topic regarding poverty, right? And poverty, it was second one, where we said that poverty level in China was more than 88% in 80s. But when it came to 2001, so that number reduced, that percentage reduced to less than 2%. China, for the sake of reducing that poverty level for such significant level, what they were doing, they were sacrificing the environment. This was one contribution. Environment was sacrificed for the sake of reducing poverty. But what China is doing now, because China's economy is really strong now, especially compared to 80s, now it's super powerful nation, okay? So now what it's doing now, they can afford, those eco-friendly technologies like wind powers, okay, generating electricity, or solar energy, and at the same time they are investing to foreign countries. They are not producing those, very environmentally unfriendly companies. They are not using at home. They are producing it somewhere else. They are doing it. So which means that at the past, what was important, poverty reduction is number one, issue. Then climate comes sometimes after. So now, at first, they tried to maximize utility because it was, the situation was not good. But now they are ready after many years, okay, and now people are paying more tax, or government is spending more from the budget in order to implement policies. So therefore, it's now 95. And future generations will be also contributing, and later, so there will be some kind, and then situation will be normal. So this is what will happen. And now again, why we are getting now, and why not? But future generations are paying more. For example, the situation that the pollution that we have in Uzbekistan, it's not because of us. It's because of our, earlier generations. Our fathers and grandfathers did all of this. And now we are paying some of it, and our children will pay some of it. So then it will be some justice, right? We don't have to pay anything. So not all. In the third case, immediate action, it means that all the burden of the climate change policy we have to take on our shoulders. We have to take it, okay? So now, for the sake of future generation, we are sacrificing, and our grandchildren are living in a very good environment. We are considering three cases. Look. Find the inter-temporal utility of each policy for discount factors of 0.999 and 0.95. If discount factor is equal to 1, students, 1, it means that we see our children's utility same as ours. We really care about them. Especially in Uzbek culture, what do we have? Parents eat less, or consume less just for the sake of their children, for them to eat more and to become a better person. So which means that we are, parents are sacrificing more now for the sake of future of their children. Okay? So because they can get higher utility. So if we see, for example, 1, then we are seeing this as same. But if it's less than 1, then it means that we are discounting our future generations' utility, okay? So now, because of the discounting factor, we will apply our formula that we have used. Utility for 200 years, okay? For 200 years. And now we are going to apply that exponential discounting factor. So period starts from period 1 to up to 200, okay? We have discounting factor, which is t minus 1, and times utility, or utilities are given. So look, now, during the lecture, students, I have shown you the numbers and the results. But I told you that I will show you where do those numbers come from. Now is considered as period 1, right? Now is period 1. 1 year, it's considered to be period 2. 50 years, it's considered as period 51. 100 as 101. Year 101. Okay, so therefore, don't get confused, because here we have 50 years, it means period 51. 100, it means period 101. Because first one is now. Okay? Good, I think it's clear. So now, from the formula of this one, we can easily implement it here. First one, a person who is people are, you know, that patient. 0.999999. 3 nines. So now, let's find, so our utility for 200 years, okay? If we are going to implement policy of doing nothing, we don't care about our future generation. So in this case, now we are implementing 0.999. First period, 1 minus 1 times how much utility? 100. Okay, 100. Second one, 0.999. Period that we have 51, right? 51 minus 1 times 100 plus. Let me write down, even though it's 0, okay? Let me write down for the sake of understanding. 0.999 period 101 minus 1 times 0 plus 0.999 in the power of 151 period minus 1 times 0 plus 0.999 in the power of 201 minus 1 times 0. And it's equal to, if you calculate this, it will give you number 195.1. Okay, this is the number that you will get. So next one, what about the second policy for 200? If climate policy ramp, step by step implementation of policies. So now 0.999 period 1 minus 1 times 100 plus 0.999. So let me just write. You already know what these numbers are, right? So it's now power of 0, right? 0. So now it will be power of 50 times 95 plus 0.999 in the power of 100 times 80 plus 0.999 in the power of 150 times 90 plus 0.999 in the power of 200 times 100. If you find this number, it will give you a number which is equal to 422.1. Okay? Next, utility of for 200 if immediate actions are taken. Immediate actions are taken. 0.999 in the power of 0 times 90 plus 0.999 in the power of 50 times 90 plus 0.999 in the power of 100 times 100, right? 100 plus 0.999 in the power of 150 times 100. And the last period, 0.999 discounting factor is the power of 200 times 100. If you find this, it will give you number which is equal to 434.
So is it, does it,
400.
utility level, right? 0, 80, 90, all these.
Yes, policies. So if you are going to apply, you know, the do nothing policy, how much utility we will expect for these 200 years? And now you can see, students, which utility gives the highest utility? Last one. So for people who really care about the future, really care, patience level is very high. So now that immediate action is the best policy to implement.
So what if we take some policies in the middle of the year, let's say in hundreds or 150, then will the remaining will change or no?
So if you are going to implement some, then it will change. Then it will change. So now, if their policy is changed from now on, then it will be structural change, yes. Then you should consider the other factor, okay? So next, students, what about if the patience level of 0.95? 95. Delta is 0.95, okay? So now, students, you can apply it. So let me quickly apply it and define, let's look at the results, what will happen. So utility of do nothing for 200 years. So now 0.95 in the power of 0, you know, right? Times 100 plus 0.95 in the power of 50 times 100. I'm not writing these zeros, okay, these zeros, because it will be 0 again, because these are zeros, right? And now if you calculate this, it will give you a number which is equal to 107.7. Okay? Second one. Second policy for 200 years, climate policy ramp, 0.95 in the power of 0 times 100 plus 0.95 in the power of 50 times 95 plus 0.95 times, or in the power of 100 times 80 plus 0.95 in the power of 150 times 90 plus 0.95 in the power of 200. It's 100, and this is equal to 107.8. If I give you just this, problem in the final exam,
So easy.
okay? If you don't have a calculator, then you don't have to even try doing it. Okay?
Thank you for motivation. Have a calculator.
So then, 200 for immediate action, 0.95 in the power of 0 times 100 plus 0.95 in the power of 50 times, oh, sorry, it's 90, right? It's 90, immediate action. 90 times 90, 0.95 in the power of 100 times 100 plus 0.95 in the power of 150 times 100 plus 0.95 in the power of 200 times 100. And this is equal to 97.6. So which one is the highest? Second one. So people are students normally they discount the future. Okay, so step by step, utility is okay, fine, policy is fine. And now we are considering the third case, students, here. Find the intertemporal utility of each possibility of policy in the case of uncertainty, in which the appropriate discounting factor is either 0.999 or 0.95. And possibility of this, the discounting factor is 50%. There is 50% probability that nations, the discounting factor will be this much, and there is another 50% probability of this much. So, student, in order to find this one, now we can simply find it. I will just show you. I'm not going to write all these things again. I am saying that there is 50% probability of happening this, or happening this, another 50% probability. So if you take the average of these two, it will give you that uncertainty. Okay, so now utility for those 200 years in the case of uncertainty, okay, and do nothing, which means there is 50% probability of this much, because we are saying that our discounting factor is this. Okay, so now it will be 195.1 plus there is another 50% probability that it will be this. Okay, this one. 107.7. And this is equal to 151.4. 151.4. Next one. Utility of climate policy ramp for 200 years in the case of uncertainty. So now we are saying there is 50% probability of this one. Yes? 422.1 plus. And there is another 50% probability of this. 107.8. If you calculate this, it will give you a number which is equal to 264.9. 264.9. And the last one, so this is immediate action. Immediate action. Immediate action in the case for 200 years of utility, in the case of uncertainty, equal. So there is 50% probability of this, 50% probability of 434 plus. There is 50% probability of 97.6. If you find this, it's equal to 265.8. 265.8. So, decision is last one. So what do developed countries are doing now?
So is it
We have to take immediate action. We have to take immediate action. Otherwise, the situation will be very bad. Because we don't know whether people's patience level is 95 or 99. Okay? It's uncertain. It's unclear. So therefore, we have to take immediate action. Okay? Immediate action. That's how do we find those numbers. Okay? All right. So students, now we have this experiment. Okay, we have this experiment, which was conducted by these two scholars. Okay, what they have done is, let me quickly explain it myself. Okay, I will explain you again. During the lecture, I tried to explain it, and I will explain you one more time. So here, the main purpose of this experiment is whether companies are exploiting time inconsistency of people. So what do those companies are doing today? So they are trying to study people's behavior, and they are trying to figure out our weaknesses, and based on those weaknesses they know about us, they are trying to maximize their profit. They are using it for profit maximization. And this experiment gives us that evidence, okay? That evidence. So let me tell you about that one. So look, students, let me erase it. Let me erase it. So look. So these scholars, what they have done, they tried to check the statistics of 3 health clubs, okay, in New England, starting from April 1997 to July 2000. And they have checked the attendance records of 7,000 members. Attendance. 7,000 members attendance. Okay? And so look, people going to the gym had 4 basic options. If you want to go to the gym, you have to choose one of the options of going there. First one is per day pay. You have to pay per day, which means that per visit you pay, and the cost was $12. You have to, whenever you go to the swimming pool here in Tashkent, if you pay 50,000 or 100,000 sums, so you can swim for 1 hour and leave. It's that type of. Second one is pay for 10 visits. In Russian, we call it usual abonnement, right? So they will give you that 10 visit ticket. So, and that price was $100. $100. Okay? So, and you know, when you go once, here, they will put 1 stamp, second time, second stamp, and if you visit 10 times, they will put 10 stamps, and you have to throw it away. That one. And the third one is monthly. Monthly. And the monthly was $85. $85. Okay? And the last one was annual. Annual. And the cost was $850. So on average, if we compare these 4 options, in which case the cost is the lowest? Annual, well, right? Let's say if you visit 12 times a week, 12 times a month, then if you divide, this one to 850 to 120, you will get something, maybe $7 or something. Here it will be give you maybe some $8 or so. Here, $10 per visit, right? And this one is 12. And look, most of the people, which one do they usually choose? Monthly, right? They usually choose monthly. This is what most of the people they do. And look, students, even though people they think if I'm going to sign for monthly, then I can pay less. But for 1 year, I don't know whether I can really attend for 1 year. For monthly is a good choice for me. They do it. And look, students. Now, these are the results, okay? The ones who were visiting paying for per visit, so average cost per visit was $12, as expected. 10 visits was $10, as expected. But now you can see those who were, signed a contract for going to the gym for the first months, on average they were paying $17. How come? Even though it's $8, that they were paying $17. Attendance was less. Because they were not going 12 times. Okay? So I do believe if you had the chance to go to the gym, first day you go very happy, very energetic. Okay, you will do your best. Next morning you will wake up all body in pain. You will say, oh, it's not for me. So after 2 weeks, because you have paid, then you will decide to go again. Okay? So that thing. So now you can see that in the case of monthly, in any case, they are paying more. More. And now, those health clubs, they really know, because for this many years of experience, someday they will come. And because of this one, what they have done is sign a monthly contract, okay, for monthly one. And what they did is, if you sign this monthly contract, you sign, and it is automatically renewed by default. Let's suppose, they are withdrawing your money from your account, $85, and then next month, automatically it will be withdrawn from your account. All right? So why did they do so? Because people have bias. For example, even though they are not going, what they did, they made a rule that if you would like to cancel this contract, you have to come, sign, I am going to cancel my contract, then they will not be withdrawing money from your account. Otherwise, they will. They know that people have bias. Okay, I will do that documentation next month. Maybe next month. They are not going, but they are paying. So which means that now they know about our weakness and they are exploiting it. Time inconsistency. Regarding annual students, here still, they are paying more, but if you compare this, on average it's less, which means the ones who are signed for 1 year, these are the people who really go to the gym. Okay, those sporty guys. I think it's clear. And the last one, students, for today. So now we will make a conclusion of the 4 modules that we have discussed. Okay, first one was exponential discounting model. Exponential discounting model, we considered delta, right? Delta, utility is discounted. And we said it does not change. Good. The best one that you may have in the final exam. Okay, the easiest one. So, second one, we said that because people's patience level increases over time, then we introduce hyperbolic discounting, which was dt. It shows. We have that alpha inside, right? And then we said, because people have bias, it will work with, that people who have no bias. Then we have introduced quasi-hyperbolic discounting model with biasness of beta. Okay, people may have no procrastination problem. Okay, and the last one we said, these things we can apply in the case of risk. So then we introduced probabilities. Okay, discounted expected utility or hyperbolic discounted expected utility that you may consider. All right, so in the last question for our discussion today, explain how differently the standard economic model and behavioral economics approach the climate change issue and offer solutions to solve the problem. From economic perspective, standard economic models, so people will be polluting less or consuming, for example, less oil, for example, gasoline, whatever, if we are going to impose some cost. If government is going to impose some cost on oil and increases the price, people will be driving less. It's good for climate. All right, there must be some cost. But what behavioral economics suggests, we have to find, it suggests that we can implement some policies, we can reduce climate change without imposing any cost. Without any cost. For example, I can give you one very simple example. In today's modern cars, okay, cars that you are driving, so if you look at the, dashboard of your car, so it shows, that the speed, right, and some light, whatever, those signs, all signs. And there is, here, sign, for example, 8L100. What does it mean? 8 liters per 100, right? Or there is another function. For example, I will tell you. So look, you purchase the car, and government made a policy. This is also considered policy. So GM, this must be big numbers, and it should be, visible to people. 8/100. You purchase the car. In the book, it's written 8 per 100. Brand new car, 8 per 100. It's there. Once you purchase the car, you are driving, and you really like speed, okay? And you pushing the gas to maximum. When you push gas, oil consumption will go up. After 2 months, you will see this number will become 18. 18, average consumption. If you don't understand what this thing is, your car consumes 18 liters per 100, why is it so? Then you will go to the dealer. I think you cheated me. In the book it was 8, but now it shows 18. How is it possible? He will explain you. Because you were pushing too much. Do you like driving fast? Yes. After that one, you will be driving less. It will give you higher cost. Or there is another function. So this, 2 dashes and 100. I think you have that thing. When you push a little more, it will show 12, 13, 20, 30, up to 40 or 50 liters per hour. And if you push slowly, it will show 3, 2, like this. Personally, I always keep it on in my car. I always look at this one. Because I know that when I push hard, it immediately reminds that I am consuming more oil. And I try to push it less, slowly. Okay? Everyone likes driving fast. So this is how behavioral economics tries to reduce that climate change. By looking this way at these numbers, just number, but you will be polluting environment less. So students, our class is over. You can go.
Thank you very much.
Yep.